Welcome to this video where we will estimate a population mean using a sample mean and a sample standard deviation. So this differs from previous estimation because we have a sample standard deviation instead of a population. So from here, from our sample, we could always calculate a mean, and from that same sample, if we had the actual data, we could calculate the standard deviation as well. So we don't really have any outside information to help us. An important thing here is that we're not going to use z-scores. We're going to use something called a t-score. So this is new, and I provide the table separately. Okay, so keep that in mind. You have a sample standard deviation. These are the formulas you're going to use. A lot of the calculations will be the same though. So here's a question. The actual time it takes to cook a 10-pound turkey is normally distributed. Okay. Suppose that a random sample of 19 10-pound turkeys is taken. Given that an average of 2.9 hours and a sample standard deviation of 0.24 hours was found for a sample of 19 turkeys, calculate a 90% confidence interval for the average cooking time of a 10-pound turkey. So here's what's given. Our sample size is 19. Our sample mean is 2.9 hours. Remember, this symbol is a sample standard deviation, which is 0.24 hours. And see, our confidence level is 90%. And what we're looking for here is the population mean. So we're going to use z-scores, which is in the textbook usually referred to as student's t-score test distribution. One thing when you use a t-score table is you have to have something called degrees of freedom. Okay, you'll see the table in just a second. But degrees of freedom is a very easy thing to calculate. The degrees of freedom is one less than your sample size. Okay, so if you remember, we're looking at 19 turkeys, so that means the degree of freedom is 18. One thing about the table we're going to use, it is not as detailed as the z-score table, so you will not have all degrees of freedom listed there. If you come up with a degree of freedom that's not on the table, you use the one that is on the table that's less than it. So if you got degrees of freedom of 57 and it's not on the table, if there's a 55, which would be the closest one below, you would use it. So here's what t-score table looks like. This is just a snippet of it. These first two rows up here will be used in a later chapter, so don't worry about them. But here you see D, F, and C. So DF is that degrees of freedom. It runs down. Here's 18 that we're looking at. And the C runs across. This is our confidence interval. So for that problem, it was 90%, which is 0.9. Figure out where those meet. The t-score we're going to use is 1.734. Okay, and there's the notation up here. T of 0.9 is 1.734. So this is like a critical value. Here's the formula. It looks very similar to when you have an estimation using the population standard deviation, but notice a couple things have changed. Here's the t-score. And here's the sample standard deviation. That's all that's different. And this is still called the error. And there's the formula by itself. So looking back at the turkey, we had all this information. We plug in, we push through. Use your calculator. Make sure you're putting this stuff in correctly. You may see different versions of the formula, but they all fall down to this. And what we have here is an interval that says the average time to cook a 10-pound turkey, we believe, with 9% confidence is between 2.8045 and 2.9955 hours. Here's a second example. It says you work for a consumer advocate agency and want to find the mean repair cost of a washing machine. As part of your study, you randomly select 42 repair costs and find the mean to be $100 with a sample standard deviation of 1750. Estimate a 95% confidence interval for the population mean. So here's all the things that we had in the sample size is 42, which degrees of freedom would be 40. But if you go back to the chart we just saw, which you may have to print out the more extensive one, there is no 41, but there is a 40. Okay? So that's what we're going to use for our degrees of freedom. Down here with the 95% confidence and the degrees of freedom of 40, we end up with a t-score of 2.021. And of course the sample mean was 100 and the sample standard deviation was 1750. Here we push through the math. Once again, make sure you can get this right. But our conclusion is we are 95% confident that the average cost to repair a washing machine is between $94.54 to $105.46. And make sure you understand, once again, like we said, this was the margin of error, so the margin of error is $5.46. Thank you.